In for this invitation, and I hope that everyone will enjoy today's talk, and maybe we can have like good discussions at the end. Yeah, so I'm Dr. Sabah Boustila, and today I'm going to talk a little bit about like designing in virtual reality, and also like mainly about like some previous research and ongoing research that I'm working on VR. And before, like when we talk about like designing, usually we think about like user experience and usability. So this is the plan for today. I'm going to talk a little bit about like UX and usability. Then I'm going to talk about like one aspect in VR, which is perception in VR, and then interaction in VR. And of course, I'm going to show you some research projects that I worked on. So I prepared quickly an introduction about myself. So I got like a PhD in computer science from the University of Strasbourg in France in 2016. And I was teaching, I was a full-time lecturer and research assistant while completing my PhD at the same University of Strasbourg in France. So I taught like computer science courses at the Department of Computer Science. After that, I did like 2 years of teaching experience, and then I wanted to have like experience abroad. So I moved to University of Toronto in Canada, where I worked as a postdoc research fellow. I worked on a virtual reality project there with Professor Paul Milgram. I'm sure that like people who work on VR, they 100% know who is Professor Paul Milgram. And after that, I went back to University of Strasbourg again, where I had like another experience of postdoc research fellow there, usually working on VR AR projects. And in 2020, I moved to Manchester, where I'm working now as a lecturer in UX design and in UX and web design. And I'm continuing working on VR and AR in my research. And so at the end, I will be happy to have any discussions if anyone is interested to talk about like broadly like about like my research or interested in any collaboration. So usually when we talk about virtual reality, when I ask my students, for example, if I teach like a VR course, so when I ask my students, what do you know about like virtual reality, or where did you experience like a virtual reality before? So most of the time, people, they think that virtual reality, they usually link virtual reality with gaming and entertainment. So this can be, I can say, maybe it was the beginning of virtual reality, but nowadays virtual reality has been included in a variety of domain and fields. So we can think about like the use of virtual reality in army. For example, it has been used as a training system, like where soldiers, they can get like in virtual environments and get training there in using virtual reality. It is also used in sports. So players, they can prepare for any competition using virtual reality. For example, if the weather condition, they don't allow them to do the training outside. So it is also a useful way to prepare for competitions. It is also used in education to teach maybe complicated concepts, for example, in mathematics or physics or any other like education course. And it has been also broadly used in healthcare. It can be used for training, for surgery training, or also to teach basics for students in healthcare, and get them to interact with the human body and different concepts that they need in healthcare or medicines. So usually, so we have to, I can say, extend our idea about VR, and we have to know that it's not only about gaming or entertainment, it is also used in more serious situations. And why we start thinking about like using VR in those, I can say, more serious situation in army, in healthcare, in any, yeah, and sports, for example. So because it allows simulating situations that are hard to physically reproduce. So if we think about like, for example, driving situations. So let's say you would like to design a new car, or maybe if we think about self-driving cars. So if we want to evaluate some features in those cars, it is like easier to create a virtual model of the new car or the self-driving car, and then use it in VR in order, for example, to assess new features or to see the human behavior, how they interact with this new car. So it is like easier to use 3D environment, like virtual environments, rather than, for example, creating the real car. It is a safe environment. If we continue talking about the driving situation, it is safer for your users to test some features of your car in the virtual environments rather than in real situations, because maybe they can have like some real accidents which can cause like serious problem. It also saves time and money. If we think about like designing and creating a new car, this is going to cost a lot of money if we just like create a car in order to evaluate features. So it is more like time consuming to have the physical car. So virtual environment here allow us to save time and money, and also it is a good tool to take this like to help you take in decisions. So again, here, if you are designing a new like some new features in a car, if you have some like different ideas and you are not sure about which idea you would like to keep in the new model, so maybe you can have a few virtual models, you can interact with them, and then from there you can think about, yeah, though I'm going to keep those features and I'm going to remove those features, and then you can move to the physical, I could say, prototype or car. So for all those reasons, usually like now, I can say in different industry, people, they tend to think about how they can include VR in industry and how they can take advantage of this tool in order to progress in their business. And yeah, so virtual reality, and usually, well, like I just like say virtual reality, but I'm talking about like virtual reality and augmented reality also, because they are like a little bit similar. Usually when we talk about VR, AR, it's similar to any other digital product, which means that we have to think about user experience. And we know that we talk a lot about user experience nowadays, especially with the fact that we are using mobile phones like every day. We are interacting with digital world like every day. So UX is becoming like more and more like popular and important in digital design. So let me talk about first introduce what is user experience. So ISO, which is an international organization for standardization, and they cover like ergonomics of human-computer interaction. So they defined user experience as the perception and responses of a user while interacting with a digital, like a product, a system, or service. So usually when we talk about user experience, we think about digital world. It's true that user experience is important in digital world, but user experience also is important with when we interact with any object in our daily life. I can say, for example, when you go to prepare your coffee using a coffee machine, you will have user experience. You will have an experience with this product. So it's not only user experience, it's not only related to the digital world, but we tend to think about it when we design for VR, for mobile applications, for website, and so on. But we as a designer, we can think about user experience with every object that we interact with in our daily life. And usually when we talk about user experience, if we are a designer, we know what it like. Usually we think about usability. I can say that usability is an attribute, one attribute of user experience. So if we have good usability, we can have good user experience. And what is usability? It is when we think about usability, we think about the effectiveness, the efficiency, and the satisfaction of users, of a group of users when they are interacting with some products. And when we think about, yeah, let me, yeah. So when we think about usability, so I mentioned effectiveness, efficiency, and the satisfaction. So when we talk about usability, we have some goals, I can say, or some attributes of usability. We have mainly, so Tom Brink, with other like authors, they defined 6 goals of usability. We have the effectiveness, which means that if your users are able to complete some tasks. For example, if you are interacting with a coffee machine, you should be able to have your coffee, like cup of coffee at the end, which means like this was effective. The efficiency, it is about like how easy was in order like your interaction in order to complete the task. Easy to learn if your how the interaction was with the digital product, how easy to remember if you interact with a product one time and then you come back a week later, if this will be easier for you to reproduce the same task, and if it's going to be easier than the first time. And then error tolerant, if a product allow your users to recover from errors if they make any, and how this will be, if it's going to be easy or complicated for them to recover from errors. And of course, we usually think about how the interaction will be with like the overall experience with your with the product, which is the pleasant side of the product. So these are, I can say, 6 factors that we usually think about when we think about usability and when we think about assessing user experience and usability of a digital product. And I'm talking about this because I'm going to cover some of these goals when we also design in virtual reality. So I mentioned at the beginning that we use virtual reality in some context in order to take decisions. And if we take decisions, we have to think about how accurate are our decisions when we use virtual reality, because our experience with a virtual environment, 100%, it's not going to be the same as if we are having the experience in real life. So there are like different, like some differences between real world and virtual environment. And we have to admit this because we are interacting with some devices rather than real world. And this will affect, so our like the accuracy of decisions made in VR will affect the effectiveness of VR, which means that if the goal is to take decisions in VR, if this is accurate, we can say that the product is effective because we were able to take good decisions. And if it's not, we have to think about how to improve the effectiveness of the VR. So I'm going to talk about like my one of the projects I worked on, and this was my during my PhD. I worked on an architecture project review in virtual environments, and this was with the University of Strasbourg. So let me introduce the project. So the context of the project is that like some architects, they wanted to include virtual reality in their, I can say, process of selling houses. So the purpose of using virtual reality in this context was to review the layout of houses in virtual environment with their client in order to make sure that everything is in order to check the client's needs and make sure that everything is properly designed for the client before to have the real house. So I can say that in this context, the main task is to take decisions to make sure that, yeah, I'm designing what my client asked me to do at the beginning. And so in this context, so use it like client, they are going to complete like some virtual visits using virtual reality with architects, make sure that the layout of the house is convenient for them, make sure that, for example, the size of the different rooms is convenient. Yeah, how the different rooms are organized and everything is what the client have been imagining in their head. And again, here the advantage is to save time and money because we don't want to build like a real house and then maybe your client can be disappointed at the end or maybe want to destroy some parts in the house and rebuild them. So this is going to save time and money for the client and also the architects. So here, as I mentioned, the task, I can say the goal is to take decisions. And if you want to make sure that VR is effective, so we have to think about what are the different factors that affect our decision making. And in this context, if clients, they will assess the size of the house, the size of the rooms. So decisions will be based on the perception of distances in virtual reality. And in this context, a wrong decision may have like serious consequences because if your users, like I can say clients, feel that the house is big enough in virtual reality, and then once you construct this in real life and they just like feel that it's smaller than what I experience in virtual reality, this can cause also serious problem. So this difference like between perceiving distances in real environment and virtual environment can have serious consequences. And there has been a lot of research about distance perception in VR, and several research have shown that distances are misperceived in virtual reality, which means that we have to be cautious when we use virtual reality in this kind of situations. And there has been also a lot of research that try to identify the different factors that can affect our perception in VR, and in order to make sure that if there is any possibility to change those factors and maybe improve distance perception. And actually, this is what I tried to do during my PhD.
I think Sabah has frozen, I think. I'm not sure it's only me or everybody else has noticed the same problem. So I think well, just write a
Hi, Nadine. Oh, you're on mute. Yes.
Hi, Monica.
Hi.
Uh,
Sabah is frozen. Yeah, there we go.
okay,
Okay.
can you hear
Hi.
me now?
Yeah.
Yeah, we can hear you.
Okay, yeah, sorry, I think I have like some troubles with network. And so I stopped the camera.
Sure, yeah.
Okay, yeah. Yeah, so here I'm going to cover some factors that may affect distance perception, because I know that if any one of you think about like including VR in any other situation, you may have like some similar factors that may affect distance, like the perception in VR. So I'm going to list some of those factors. So overall, we can think about three factors that may affect the perception inside the virtual environment. I can say technical factors, compositional factors, and human factors. All these factors can have some, can affect our perception in different ways. And from there, if you are assessing perception in VR, the distance estimation can be also either misperceived or over. VR. So here's are some information about technical factors. Technical factors can be, first, we can think about which display device we are using. Most of the time, I know that nowadays VR headsets are the most known because they are not expensive. I can say that they are more affordable. If I remember, like I got the Oculus Quest 2 last year, and it was £400. I can say like it's cheaper than like some smartphones nowadays. So most people, they think about like only VR headsets, but we have many other VR display devices. We have what we call caves. It's the picture on the left side, where you can see the person is experiencing kind of like a full room with VR, with virtual environments like projected on the walls and the ceiling and the floor. So this is another way to display virtual environments. We have on the right side, we have another display device, which is one wall display device. So you can see the virtual environment in front of you on a large screen. And when we have also 3D glasses that users wear, and so they have the 3D glasses, so they can see the depth, they can experience the depth in virtual environment. So we have to think about like what is the display device that we are using. And so the display device, how it will affect. So if we are wearing the headset, so the screens, I can say the VR headset in the middle, the screens are just like in front of your eyes. So you cannot see your body. You just like see the virtual environment. If you are experiencing the cave or the wall, so you can see that the field of view change, which means that what you see surrounding you, so in the cave on the left side, so we can see the virtual environment surrounding us, but we can see also our body. In the wall screen, we can see the virtual environment, but we can see also the real environment. If you turn right or left, so you can see the room, the real room. So all this technical factors, like the possibility to see ourselves, the field of view that the virtual display device provide, affect our perception in virtual environment. And it affects also the experience, because if we are wearing the Oculus Quest, for example, we are fully immersed because we cannot see the real world at all. We just like see the virtual environment. While, for example, if we think about the wall screen on the right side, so you can see that it's not fully immersed, because if someone else come on the right side, even if they don't talk, you will be able to see them. They will interrupt the experience. So it's not like fully immersed as the Oculus or any other VR headset. Human factors, we can think about like what are the human factors that like parameter that can affect our distance perception. And several like studies have shown that gender affect distance perception. So they're like, if we think about like men and women, we can usually like studies, they have shown that women are less accurate in distance estimation. There has been also different studies about the age and distance estimation. For example, studies, they showed that children, or I can say like adults, they are more accurate in distance estimation than elderly people, or maybe people beyond like 35 years old. And also our perception of distances in virtual environment and also in the real environment, I can say, is affected by our knowledge in distances. So for example, myself, I can admit that I'm not good in distance estimation. So for example, if I ask you about a shop on the street and you tell me that the shop is 100-meter away, I will be unable to imagine what is 100-meter, honestly. So it is about like also the knowledge of people in distances. If they know, like if you also tell me that this room is 5 meters square, so some people they can understand this, or some people maybe because they don't use distances in their daily life, they can be like less accurate in their distances and also in their imagination. So all these are human factors that may affect our perception in virtual environment. I will also mention another one, which is the cognitive profile. I did not list it here, but it was one of the parameters that as I can say, investigated in my research. And when we talk about cognitive profile, I think it's very used in education. We know that like people that, so previous works, they show that we have three cognitive profiles. We have the visual profile, where people, they rely on visual aspects in, for example, learning or completing some tasks. If we are talking about distance perception, people, they can just like rely on visual aspects. If we have another profile, which is the auditory profile, and in this profile, people, they rely on any audio that may help them completing tasks. So for example, we can think about like people who prefer listening to podcasts or listening to any videos in order to learn something rather than reading. And we have the kinesthetic profile, in which people, they prefer doing things rather than listening or maybe reading something. So for example, if we talk about like completing, let's say any mathematical exercise, maybe some people, they prefer go and read more knowledge, like extend their knowledge by reading. Some other people, they prefer like go and do like watching any videos about this, and some other people, they prefer doing things in order to learn by themselves. So this is the kinesthetic profile. So we can also think about the cognitive profile when we talk about like human factors and how this profile can affect our experience in VR. The compositional factor, we have to think about like, if we talk about compositional factors, in this situation, I will say it is about the virtual environment itself. As I mentioned previously, it is about the possibility or the ability of users to see themselves. It's in some situations, for example, when we talk about VR headsets, and most of the time, if we feel that when we design a virtual environment and we feel that it is important to see ourselves, we tend to design avatars, either a full avatar or maybe just like the hands, if the task is mainly based on hands. We can think about what are the different elements present in the virtual environment. So for example, let's say in my situation, I worked in architectural project review, and it was about indoor situations, houses. So we need to think about, are those houses furnished? Do we have any, I can say, visual cues about size, the size inside the virtual environment? For example, the picture like on the bottom right corner, so you can see a room with a lot of furniture. So those furniture can be used as visual cues in order to have some familiar objects and be able to use them, for example, in order to assess the size of the room and the house itself. So there is also a difference between experiencing an indoor and outdoor place. Outdoor places, I could say they are large. So in this situation, most of the time research are about like large distances beyond 10 meters. And this also affects our perception of distances. Here I'm talking about, I'm not sure if you can see the compositional factors slide 16.
In my case, I can see it, but I'm not sure the rest of us.
Oh, yeah, I should be, let me change it. And now can you see slide 17, for example?
Can anybody confirm if you can see slide 17? No, I cannot see it. No, it's not moving.
Okay, let me go back to the, okay, now I'm in 13 and I'm updating to the 14th. Can you see the 14th?
Not yet. Not yet. I cannot see 14. No.
Okay, let me stop sharing and sharing it again. So
I think perhaps something went wrong when you freeze.
yeah.
I think the slides freezed a bit. For me, we're moving, but because I clicked the synchronize with the presenter, so I thought maybe it was synchronized with you. So I'm not sure what went wrong, but here we are.
Okay, I apologize for that,
No
and
worries.
thanks a lot for
No
letting me
worries.
know.
No worries, it happens. No worries.
Because if you cannot see the slides, it's going to be a little bit complicated to follow what I'm saying. So let's quickly move to the, so yeah. So can you see it now? So this is the 13th, and then
Yes.
I'm moving to the 14th.
Yes, I can see it.
Oh,
yes.
yeah. I apologize because I think you missed a lot because I was talking about mainly pictures and you were unable to see them.
No worries, I could imagine it. I think the rest would
Okay, yeah.
Okay.
Yeah, please let me know if there is any other technical problem and we try to fix it before. Yeah.
Yeah, sure. Thank you.
Yeah, so I was talking about like here the compositional factors. It's about like the possibility to see your body and also what are the other different components available in the virtual environment that may help you assessing distances in virtual environment. So all these factors affect our perception. And because we cannot assess all those factors in one project, because it can be very complicated. So in my research project, I just like focused on a few, and I did some experimental studies related to those factors. So I investigated navigation speed because in this project, so we were talking about completing some virtual visits, which means that users, they need to move around the house, make sure that they can see all the rooms and, for example, the living room and everything. So navigation is one important aspect in this context. The virtual content, which is like the, I can say the compositional factor. So it was about like assessing furnished houses and unfurnished houses. And as I mentioned previously, I also investigated the cognitive profile. Why I thought about like cognitive profile, because mainly virtual environments is based on visual aspect, because we are experiencing virtual environment, we're in a headset, and most of the time the thing that we can experience is the 3D environment. So we can think about if this is going to be more helpful for visual people, maybe auditory people, they will be they need more other cues in this situation and so on. And also, I did not mention this when I talked about the technical factors, but I also investigated stereoscopic vision and head tracking in this kind of situation. Because in some contexts, you can just like have the 3D environment, but you cannot experience the stereo, which is the depth, the perception of depth in virtual environment. So I investigated those different factors. So I could say I tried to cover the human factors, the compositional factors, and the technical factors also. And some of like I mean, after completing those experimental studies, we tried to suggest some guidelines for architectural project reviews. Yeah, in order to help maybe people in this kind of industry, if they would like to have VR in their in the industry, so they can just like follow those guidelines in order to have like I can say not accurate but good distance perception. So we found out that slow navigation speed was good for distance perception. So people, they were more accurate when they walk in slowly inside the virtual environment, and also the virtual visits, that it was easier for them. So the navigation speed can affect also user experience, because if we are moving fast, we can have some problems with, I can say, what we call simulator sickness. And simulator sickness is the fact of like people feeling sick while experiencing virtual environments. So this is what we call like simulator sickness. So moving slowly allow our participants to have a good user experience, and the virtual visits was easier for them. And because in this situation, we can expect a wide range of users going from, let's say, I don't know, like young people who want to get, like, for example, their first house, maybe young adults like within their 30s who want to buy like their first house, to elderly people who would like to change their house or whatever the reason is. So we can think about like a wide range of users. And in this situation, we have to make sure that we provide a good user experience for everyone. So one of the guidelines was to use a slow navigation speed, and we found out that users with visual profile were more accurate, because as I mentioned, the visual profile, they rely on visual aspects. And in this situation, because it was just like 3 years of like research project, we did not have time to complete that. But one of the ideas is to add other cues, like, for example, audio cue, for example, steps while moving, like audio of like the steps while a person is moving around, can help people in distance perception and distance estimation. Because if we hear our like steps, we may know like more about like the distance that we have been walking when we were like visiting the house, and this may help us in distance perception and distance estimation. And one of the guidelines was also to use furnished houses, because by having like some furniture inside the room, we can have a sense of scale, and we can rely on, as I said, like our previous knowledge in distances. So for example, we can have some standards, standard knowledge. For example, a door, it has like some specific standards in the width. A table also, we can know, like we can estimate a little bit or imagine a little bit the height, the normal or the average height of tables, and we can compare this, or we can use our knowledge in real life, and we can we can use them in the virtual environment in order to assess like distances in virtual environments. And so we also compared stereoscopic vision and head tracking, and we found that those two factors, they did not, I can say, affect distance perception or spatial perception in virtual environment. So sometimes why we were interested in those like stereoscopic and head tracking factors, because they can also increase simulator sickness. Sometimes if we wear like headsets for a long time, and if we are having the stereoscopic vision for a long time, we may have some headaches. And sometimes it can be useful if we want to have like, I don't know, like few virtual visits with one person. We can think about maybe removing the stereoscopic vision in order to decrease the fact that maybe this person can have a headache after some time. I'm not saying that stereoscopic vision is like will cause like a headache, but it can be one of the factors that may affect like the experience in virtual environments. So we found out that we can remove stereoscopic vision and head tracking if it's not necessary. So these are like some contribution in in this context, and we tried to help industry in this context and provide some guidelines for them in order to make sure that they can properly, like users, they can properly have like a good perception in virtual environment as well as good user experience. So this, like the first project, was mainly about the effectiveness of virtual reality in the context of architectural project review. And I have been also working on other goals of usability. I mentioned efficiency, which is how quick users will be able to complete a task. Learnability is also about like how much time your users will spend in order to understand your design when they interact with it the first time. And the memorability is about like how easy it's going to be for them to reuse the product again. So I'm going to talk about those three attributes, usability attributes, in relation to another project. So when we think about like the speed and how easy to learn and how easy to memorize aspects, we need to think about like maybe to link that into VR. And in virtual reality, in addition to perceiving the virtual environment, we also interact with the virtual environment. We can select objects. So we have mainly, if you do research about VR interactions, so you are going to find those three elements. Selection, which is about like selecting objects in the virtual environment or augmented reality. Manipulation, which is like, so you select an object and then you are going to move it or manipulate it, take it from one place to another. And locomotion, and as I talked about, like in my previous project, I assessed the navigation speed. So locomotion is related to when your users move around the virtual environment in order to complete some tasks. So for example, in the architecture project, it was to complete some virtual visits. So those are three interactions. We need to think about how we can improve the user experience when they complete those three interactions. So as I mentioned, one of the most popular VR display devices is VR headsets. So I just like I'm providing an example here, which is the Oculus Quest, but it's not only Oculus Quest. So we can have HTC Vive and different other brands that provides like VR headsets. So when we interact, so we have the virtual headset, and also in order to select objects and manipulate them and also navigate around the virtual environment, we need to interact. So we have the hand controllers that you can see on the right, like the right and left side of the VR headset. So we usually have some hand controllers in our hand in order to complete those VR interactions. And I'm talking about this because it is the most affordable display device that we use nowadays. And I can say, as I'm working in VR, most people who try to include VR in their industry or in their project, they usually tend to get those VR headsets because, as I mentioned, they are the most affordable, and because they are the most affordable, people, they will also be more familiar with them. But of course, if we think about the user profiles, because when we talk about user experience, we think about also what type of users we will have. And here we cannot say, oh, we will have young people. We can provide like VR experience to everyone. And people, they may have some difficulties when they interact with hand controllers because they are not familiar with those different buttons. So you can see now, so I'm just like focusing on the hand controller. So you can see that we have a joystick and we have different buttons that we can use, for example, to select an object, and then you can click on another button in order to move forward and backward. So this can be sometimes can be overwhelming to new users, which can affect the learnability of the product. And so as I'm designing this, I'm trying to see how I can simplify or how I can improve the user experience and usability of virtual reality. We know that nowadays we are interacting, I can say, most of the time with our smartphones. We use a lot our smartphones for a variety of tasks. We can do text typing, we can text each other, we can write emails, we can check our emails using our smartphones. We can also just like browse online, we can browse social media. So we can just like swipe up and down using our smartphone interfaces. So my objective is to explore and design interactions for virtual headsets using smartphone interfaces. So in this situation, I will say, let me go back to this slide. So I'm trying to think about how I can help users to complete tasks in effective way, which means that I'm trying to help them to decrease the time they need to complete some tasks and also decrease the time in learnability, because if we interact with our smartphones in every day, we know how to do that. And I'm thinking about how we can bring those interactions in VR and replace the hand controllers with just like our smartphone interfaces. And because we know how to interact, so we know like the memorability of the interactions, we are already familiar with them. We don't need to learn something new. And it will be good if we can just like use those familiar interaction rather than the hand controllers. So I started exploring text typing using smartphone interfaces in VR. So the purpose of this project, so this project was conducted with University of Tohoku in Japan. So we tried to, as I mentioned, the purpose is to replace hand controllers by smartphone interfaces. It will has a lot of, I can say like some advantages. You can get rid of hand controllers and you can just like have the VR headset and your smartphone that you use in your daily life. So you don't need a new smartphone. You can just like connect your smartphone to the VR headset, and then you can just like interact with it using the smartphone interface. This also can, if we can achieve a good efficiency and learnability, if we can validate this kind of idea, we can also decrease the cost of VR headset, because you will need only the headset rather than the headset plus the hand controllers. So in this project, we tried to assess text typing using smartphone interfaces. So because when we wear headsets, so we cannot see our hands and we cannot see the smartphone interface. So you can ask yourself, oh, how can I write text if I cannot see the smartphone interface? So the idea was to reproduce the smartphone interface inside the virtual environment in a way that we have our smartphone in our hands. We interact on, like we can have our fingers on the smartphone interface, and at the same time, we can see this in the virtual environment. So there is no need to remove the headset in order to see the smartphone interface and our fingers. So we represented the smartphone interface plus the fingertips, because we need to see where our fingers are on the smartphone interface. So if you can see in this, the picture here, so you can see a green circle on the keyboard. So you can see that this is where the fingertip is. So you can see the person here has it having his like finger on the smartphone interface, and it is represented in the virtual environment by the green circle. And we use the confirm on release principle, which is if you are moving your finger on the smartphone interface, you are not going to execute any action. However, when you release your finger from the interface, you are going to type a letter in the virtual environment. And yes, if you are writing, you need to see a visual feedback, which means that you need to see the word written also in the virtual environment. So this is what you can see on the top. So we provide users with one sentence, and we ask them to rewrite it using the smartphone interface in order to assess the speed and yeah, the how easy it's going to be for them to complete this task. And I'm going to show you, so this, I have this video, I hope it works. So this is a video where like the user here is typing the same sentence using the smartphone interface. And we're in the, here we have the HTC Vive in this project. So you can see that it's in real time. So if user is typing something or is correcting the word, so they have like a real time visual feedback. And we compared this with hand controllers. So we have, so here you can see that the user is using 2 hand controllers. And you can see that each hand controller is represented by, let me just see. You can see some rays, green rays that show like the hand controllers. And then we also compared the efficiency with gamepad. So the gamepad, so you will be able to see that in the video. So here the user is holding the gamepad and trying to rewrite the sentence on the top. We asked users to correct their mistakes if they do any when they are while they are writing the sentences. So it was not only about speed, but it was also about the correctness of the sentence itself. We also, because we would like to, I can say, replace hand controllers with smartphone interfaces, we also investigated this. We did not do an experimental study on navigation, but we just like tried to design navigation using smartphone interface. So here the user is navigating in a forest and exploring the space. So you can see that by just like moving their head, so they can change the direction, and by so they can swipe their fingers in order to move forward and backward. So this is another project, but it is also based on using, like comparing hand controllers and smartphone interfaces. So in this situation, we had a, this was like the 3D environment of London City, and this is the map of London City, and they are aligned. And it was about like navigating in London City using this map. And it has, you can see some 3D landmarks. I think because you are in London, you may be able to or recognize some landmark buildings in London City. So we asked users to interact with this map and the different features we provide with this map using hand controllers and using smartphone interface. So this is another context. So you can see that with the map, we have some features. We can select some places. So for example, here we asked participants to find a restaurant. So they selected this and the features, and then at the end we asked them to select one place and go there. So this is using the hand controller. So you can see the ray, the purple ray casted from the hand controller. So this map can be like, it's a real map and it has some real features. So it displays the path to some places, and then users, they can just like navigate inside the virtual environment and go to this place following the path displayed by this map. And this is the interaction using hand controller. So it is exactly the same. It has the same principle. So you can see the same map with the same features. And the interaction here is using the smartphone interface. You can see the red circle. It shows where the finger is on the smartphone interface, and it uses the confirm on release concept or principle, which means that when you release your finger, you can select some, a place, or you can change the map parameter and complete some tasks. So it has like the same features, but the attraction is different. So when we compared, so with the map, we did not do experimental study yet, but we compared text typing and using smartphone interfaces and their gamepad and hand controllers. And we found out that there was like some familiarity behavior. As I mentioned, having the sentence correct also at the same time, then writing it like the speed. So participants with smartphone interface, they tend to correct sentences. So we had less error with a smartphone interface because we do that in our daily life. We write text using our smartphone in every day. So users, they had this kind of familiar behavior. So they kept this in virtual environment. And we also found out that, so SAC is smartphone as a controller, smartphone interface as controller. So the word per minute. So we investigated the word per minute, which is the speed. And we found out that this was in accordance with previous studies. So we had like a good average of word per minute, like which is the speed when typing with a touch screen keyboard in another study. And I would say that a smartphone interface, it was faster than the gamepad. So we can see that, I mean, after doing this study, I'm still working on this project because as I mentioned, we have the selection, the manipulation, and the navigation. And here we just like investigated one aspect, which is text typing also in VR. And I hope to extend this in the future and try to achieve, I can say, my goal, which is replacing hand controllers with smartphones, because everyone is using smartphone, going from young people to elderly people. And if you give them like a headset plus their smartphone, they can accept this kind of, I can say, new tool. So I will just like summarize quickly. So because I have been working on user experience in digital product, like a digital world, and virtual reality and augmented reality, I will just like say that usually we have to think in VR, VR is, or VR AR, they are like similar to any other digital product. So we have to think about user experience. We have to think about also that the novelty of the tool itself, because some people they may have they may have never used this product before. So we have to think about how we simplify the design for our new users and how to help them achieve good usability and good user experience. So in order to do that, we have to identify the most important factors involved in task completion. So if I say in my project, in my PhD project related to architectural project review in VR, so I tried to ask myself, what is the task? And what are the different factors? And how can I improve the user experience plus the efficiency? Because sometimes I mean, some people, they contact me from industry or from other research labs in other fields asking, how can we include VR in our, for example, project or industry? So usually we have to think about the like why we would like to include VR in this project. What is the advantage? And from there, we have to think about how we simplify tasks, because we can deal with people who have never used this kind of technology, and we have to make it like familiar to them and think about how to simplify and use familiar interactions. So I hope that this talk was helpful, and yeah, for people who have like experience or non-experience with VR.
Thank you, Sabah. Very impressive. I liked very much the idea of replacing